Now, looking at this last expression, part of it a plus I is a simple addition using the plus operator, and the rules of C state that such an expression is commutative. That is, a plus I is identical to I plus A. Thus, we could write star I plus A just as easily as star A plus I. But star I plus A could have come from I of A. From all this comes the curious truth that if char A of 20 int I, writing A of 3 equals x, is the same as writing 3 of A equals x. Try it. Set up an array of characters, integers or longs, etc., and assigned the third or fourth element a value using the conventional approach, and then print out that value to be sure you have that working. Then reverse the array notation as I have done above. A good compiler will not balk or shy away, and the results will be identical. A curiosity, nothing more. Now, looking at our function above, when we write dest of I equals source of I, due to the fact that array indexing and pointer arithmetic yield identical results, we can write this as star dest plus I equals star source plus I. But this takes two additions for each value taken on by I. Additions, generally speaking, take more time than increments, such as those done using the plus plus operator, as in I plus plus. This may not be true in modern optimized compilers, but one can never be sure. Thus, the pointer version may be a bit faster than the array version. Another way to speed up the pointer version would be to change while star source not equal to \0 to simply while star source. Since the value within the parenthesis will go to 0, that is false, at the same time in either case. At this point, you might want to experiment a bit with writing some of your own programs using pointers. Manipulating strings is a good place to experiment. You might want to write your own versions of such standard functions as strlen, strcat, strchr, and any other you might have on your system. Some more on strings and arrays of strings. Well, let's go back to the strings for a bit. In the following, all assignments are to be understood as being global, that is, made outside of any function including main. We pointed out in an earlier chapter that we could write char myString of 40 equals TED, where T is uppercase, which would allocate space for a 40-byte array and put the string in the first 4 bytes, 3 for the characters in the quotes and a 4th to handle the terminating \0. Actually, if all we wanted to do was store the name TED, we could write char my name equals TED, where my name is an array, and the compiler would count the characters. Leave room for the null character and store the total of the 4 characters in memory location, the location of which would be returned by the array name, in this case my name. In some code, instead of the above, you might see char star my name equals TED, which is an alternate approach. Is there a difference between these? The answer is yes. Using the array notation, 4 bytes of storage in the static memory block are taken up, one for each character and one for the terminating null character. But in the pointer notation, the same 4 bytes are required, plus n bytes to store the pointer variable my name, where n is the size of the pointer variable, that is system dependent. In the array notation, my name is short for ampersand my name of 0, which is the address of the first element of the array. Since the location of the array is fixed during runtime, this is a constant but not a variable. In the pointer notation, my name is a variable. As to which is the better method, that depends on what you are going to do within the rest of the program.